Welcome. Chemical changes are happening all around us, all the time. Think about an egg cooking or a nail starting to rust. But have you ever stopped to wonder, how do we know a chemical reaction is actually happening? Well, today, we're going to become chemical detectives and hunt for the clues.
So, that's the big question, isn't it? And to figure it out, we're going to have to look for some evidence. Let's dive into our investigation with a few simple hands-on activities. Okay, first up for our investigation, we've got this simple, silvery, metallic ribbon. It's made of magnesium. Let's see what happens when we introduce it to a flame.
The process itself is really straightforward. We just take a clean strip of this magnesium ribbon and heat it up. But the result, well, it's anything but simple.
Wow! Look at that! The very first thing you notice is this incredibly bright, dazzling white flame. It's so intense. That's a pretty clear sign that something major is taking place. And then, after the light show is over, look what's left behind. That shiny, metallic ribbon, it's gone. And in its place, we have this white, powdery ash. That's a totally new substance called magnesium oxide.
So, here's the key takeaway. We started with one thing, a shiny metal, and we ended up with something completely different, a white powder. This transformation into a new substance with totally new properties, that's our first big clue that a chemical reaction has definitely occurred.
All right, that was a great first clue. Now let's move on to our second experiment and see what other kinds of evidence we can dig up. For this one, we're going to take a few little pieces of zinc metal, we call them granules, and put them into a flask. Then, we'll carefully pour some dilute acid right on top of them. And just look at that. The reaction is immediate. The second that acid hits the zinc, you see it start to fizz. Bubbles of gas just start forming all over the surface of the zinc granules. And you know what? There's another clue here. If you were to carefully touch the side of the flask, you'd feel it getting warmer. So in this one little experiment, we found two more signs of a chemical reaction. A gas is being created and the temperature is changing.
Okay, for our final piece of evidence, let's see what happens when we just mix two clear liquids. You might think, well, nothing's going to happen, but you should watch closely.
So, we're starting with two different solutions, lead nitrate and potassium iodide. As you can see, they both look just like water. Totally clear. But check this out. The moment they mix, boom, a vibrant yellow solid appears, almost like magic.
Seeing a solid suddenly form when you mix two liquids is just a fantastic clue. This solid, by the way, is called a precipitate, and that sudden, dramatic change in color is another unmistakable sign that a chemical reaction has just happened.
So, let's step back a second. What have our three little investigations shown us? We've actually gathered some really solid clues about how to spot a chemical reaction while it's happening. Let's put it all together. Okay, let's review our detective work. We can now be pretty darn sure a chemical reaction has happened if we see one or more of these things. Remember, we saw a change in state when that solid ribbon turned into a powder. We saw a big change in color when the clear liquid suddenly became yellow. And with the zinc and acid, we saw gas bubbling up and we felt a change in temperature. These are the key observations you need to look out for. So now you've got the tools. You can spot the signs of a chemical reaction happening all around you. But, just spotting them is the first step. The next big question is, how do we actually describe these reactions using the language of chemistry? And that's exactly what we're going to explore in our next explainer. Thanks for joining me.